Hello everyone, today in this video I will solve some chapter 9 exercise questions, that is 9.5, 9.6 and 9.7. Now move on to our first question, that is 9.5, and the question is two wires of diameter 0.25 cm, one made of steel and other made of brass, are loaded as shown in figure 9.3. Here is figure 9.3, you can easily see this. The unloaded length of steel wire is 1.5 meter and that of brass wire is 1 meter. Compute the elongation of the steel and the brass wire. Here is a question, and now firstly we will write what is given. Unload length of steel equals 1.5 meter, the original length, and original length of brass equals to 1 meter, or you can also credit unload length, and load on steel wire equals to 10 kg and load on brass wire equals to 6 kg. How the load on steel wire is 10 kg but in the diagram it's shown 4 kg? I will tell you when I calculate elongation. Now we firstly from the table of Young's modulus we get the Young's modulus value of steel equals to 200 into 10 to the power 9 Newton per meter square, and Young's value of brass equals to 91 into 10 to the power 9 Newton per meter square, and diameter of both wires equals to 0.25 meter. And now firstly we have to calculate elongation of steel wire, then later we will calculate elongation of brass wire. So force equals to 4 kg plus 6 kg, that is, so weight of this or force on the steel wire equals to 100 Newton and length equals to 1.5 meter and R equals to 0.25 into 10 to the power minus 2 meter, and value of Young's modulus is 200 into 10 to the power 9 Newton per meter square. As we know that Young's modulus equals to force into length by area into delta L. For finding the elongation of steel wire, the formula will change as delta L equals to force into L by A into Y. Then after writing all the value that we know, we get a final answer of elongation of steel wire equals to, that is, 1.49 into 10 to the power minus 4 meter, and after round out we can write it as 1.5 into 10 to the power 4 meter. Now we will calculate the elongation of brass wire by the load. So in this the force equals to 6 kg into 10 meter per second square equals to 60 Newton. A length equals to 1 meter and radius equals to 0.25 into 10 to the power 2 meter, and value of Young's modulus equals to 91 into 10 to the power 9 Newton per meter square, and here area equals to pi into 0.25 into 0.25 into 10 to the power minus 4 meter square. Now elongation of brass wire, after using the values in the formula that I told you later, we get a value of elongation of brass wire equals to 1.3 into 10 to the power minus 4 meters, and that is the answer. Now move on to our 9.6 question. The edge of an aluminium cube is 10 cm long. One face of a cube is firmly fixed to the vertical wall. A mass of 100 kg is then attached to the positive face of a cube. The shearing modulus of aluminium is 25 GPa. What is the vertical deflection of the face? Firstly, we will write what is given. Length equals to 10 cm or 0.1 meter, and area of cube equals to 0.1 into 0.1 meter square, and force equals to 1000 Newton. Here shear modulus equals to 25 GPa. As we know that shear modulus equals to shearing stress by shearing strain, we have to find shearing strain. So shearing strain equals to shearing stress by shear modulus. So shearing strain equals to force by area by shear modulus. So after using the values that we know, we get a final answer, that is 3.92 into 10 to the power minus 6. So note it down. Now according to question we have to find the lateral strain, or that is vertical deformation. So shearing strain equals to lateral strain, that is delta x by side of cube, that is L. So delta x is equal to shearing strain into length, and after using the values that we know, delta x is equal to 3.92 into 10 to the power minus 7 meter. After round up we can also write it as 4 into 10 to the power minus 7 meter, and that is the answer. Now move on to our 7th question, or 9.7. Four identical hollow cylindrical columns of milled steel support a big structure of mass 50,000 kg. The inner and outer radius of each column are 30 and 60 respectively. Assuming the load distributing to be uniform, calculate the compressible strain of each column. Firstly, we write what is given. Total mass of 4 cylinders equals to 50,000 kg and mass of one hollow cylinder equals to 12500 kg, and weight of one hollow cylinder equals to 1,25,000 Newton, and value of Young's modulus of steel equals to 200 into 10 to the power 9 Newton per meter square, and radius of inner column equals to 0.3 meter and radius of outer column equals to 0.6 meter. Then area of cross sectional of each cylinder column, the formula equals to pi r2 square minus r1 square, and after using the values we get area equals to 0.84 meter square. And now we will use this area in the formula, as we know that under compression the Young's modulus equals to compressive stress by compressive strain. We have to calculate compressive strain, so compressive strain equals to compressive stress by Y, and we can also write as compressive stress by force by area, and after using all the values we get strain equals to 1,25,000 Newton into by 0.84 meter square into 200 into 10 to the power 9 Newton per meter square, and we get 0.7 into 10 to the power 6 meter. Now compressive strain for all 4 columns we get 0.7 into 10 to the power minus 6 into 4, and the answer is 2.88 into 10 to the power minus 6, or after rounded we can also write it as 3 into 10 to the power minus 6. Thanks for watching. If you like this video, so like and comment, and hope you understand the topics, numericals.